This video is finding confidence interval for a difference between two means.
Okay, a very good day. We are going to continue the confidence interval for a difference between two means. Continue the second example. Where the learning outcomes is find the confidence interval for difference between two population mean where both sample size are greater than 30 or the population variance are known. Okay, the example 7 cause continuous from the previous confidence interval for single mean, and example 6 is confidence interval for difference between two population means. Okay, the problem is, okay, does smoking damage the lung of children exposed to parental smoking? Then we have the force. Okay, it got the use the force vital capacity FVC is volume in milliliters of air that an individual can exhale in 6 seconds. FVC was obtained for a sample of children not exposed. Okay, here, not exposed to parental smoking, and group of children exposed to parental smoking. So we have the table below here, parental smoking. If yes, then the FVC mean is 75.5. Mean the claim is FVC for not exposed. So it's here. Not exposed to parental smoking, they have a higher FVC with their standard deviation and number of sample. Okay, what is the claim here? Volume in milliliter of air. So mean those are not exposed to the parental smoking, they will have higher FVC lah, because they got more air. Those exposed to the parental smoking, they got the lower air that an individual can exhale in 6 seconds. So the claim is, does smoking damage the lung? Does smoking damage the lung? Hence, we can find the difference between these two mean. These two mean, yes, is those smoking. Smoking, they should have lower FVC lah compared to those not exposed to parental smoking. We want to know whether parental smoking decreases children lung capacity as measured by the FVC test. So you see that those exposed to parental smoking, they have exposed to parental smoking, they got the lower FVC, so mean lower air that can exhale in 6 seconds. Then we use 95% confidence interval. Is the mean FVC lower in the population of children exposed to parental smoking? Children exposed to parental smoking, let's say is a population 1. So means we would like to test whether the mean of mu1 less than mean of mu2, or mu1 minus mu2, less than 0. So again, these are the data in the previous slide. I want to know whether those children exposed to parental smoking will be the population 1, their mean will be less than. So mean the mu1 less than mu2 or mu1 minus mu2 should be less than 0 lah. And then we use, since n here exactly equal 30, and we use a Z distribution table with this formula. This is the sample mean between these two populations plus minus Z alpha over 2 times square root of the this is a standard deviation, the variance for the sample 1 divided by number of sample 1 plus variance of sample 2 divided by numbers the sample size of the population 2. Okay, and then here we would like to show in the calculator here. So in the previous video, we have key in the formula bar x1 as A, bar x2 as B, Z alpha O2 as a C. Okay, and then we can search by, I think, the first lower confidence limit formula, which is minus C. Okay, S1 squared as a D, N1 as a E, S2 squared as a F, N2 as a M. Okay, and then how many? 95% confident interval. Alpha is 0.05 alpha over 2. Okay, alpha over 2 will be, okay, we refer here, alpha over 2, 0.025. Z alpha over 2 will be 1.96. Okay, 1.96. So again, using the same formula, we calculate. Okay, now A is a sample mean 1, 75.5. Okay, B is a sample mean for population 2, 88.2. C is a Z alpha O2, 1.96. D is a variant for sample 1, which is 9.3. In from here, yeah, 9.3. 9.3. E is a sample size for sample size for population 1, 30. F is the variant for, so this is S squared, S squared, variant for population 1, population 2, which is 15.1. M is a sample size for population 2, 30. So we get let's see. Hold on, check back the formula. Calculate. A 75.5, B 88.2, C 1.96. Okay, sorry. D, since I key in the D, let me see. Okay, given this is S, sorry. Okay, given this is S, hence my D I should, given this is S, and the formula that I put up is a variant, so my DS should 9.3, the variant, 9.3 squared. E correct. F should have 15.1 squared. So I get, negative 19.0461, 0461, or 2 decimal place, negative 19.05. Let me search the formula for here, for the upper confidence limit formula. So calculate, the same A, B same, C same, D 9.3 squared, E 30, F 15.1 squared is value, M here, it gets the the upper confidence limit negative 6.35, negative 6.35 if you want 4 decimal place, 3539. This one is negative 19.0461. Okay. So you get the value here, the confidence interval. So it's also at the negative range, where the mu1 is the mean FVC of children with a smoking parent, mu2 mean of FVC of children without smoking parents. So this 95 confidence interval for mu1 minus mu2. So we are 95% confident that the lung capacity in children of smoking parent is between 19.05 and 6.35 milliliter less than in children without a smoking parent. This negative range because we use population 1 deduct population 2. Population 1 is smoking. So smoking, they got the lower mean. So the lower deduct the higher, that's why it's in the negative range. If we use lung capacity in children of smoking, smoking is between correct because we said less than in children without a smoking parents. Okay, smoking deduct the not smoking, so we get negative. And why the value here positive? Okay, why we call positive? Because the here is actually less than in children without a smoking parent. The FVC is actually measured the lung capacity in terms of milliliters. Okay, so with this, thank you. We revise back the formula that we use. Oh, I didn't put up the formula. The formula is this is a formula. When the sample size greater, both sample size greater than 30, we use the Z distribution table. So with this, thank you for your attentions.